We said that for systems of simultaneous equations to be solvable, the number of equations must be equal to the number of unknowns. When there are more unknowns than equations, we say that the system is not solvable. However, there is one exception. If the equations are the what we so-called Diophantine equations, named after the Greek mathematician whose name is Diophantus, these are equations wherein all unknowns are whole numbers. If all unknowns of equations are whole numbers, they are Diophantine equations. And in dealing with Diophantine equations, even there are more unknowns than equations, the system of equations is still solvable. So, the solution is following a certain system I call the systematic trial and error. And the system is this. One is find the K equation. You will know the K equation if U minus A plus 1, U is the number of unknowns, A is the number of equations, plus 1, it is the K equation if it contains this number of unknowns. I'll explain it with the solution of this problem. Now, once you have the key equation, express that key equation as in the form of y is function of all other variables. So, dalhin nyo lang sa kaliwa yung isang unknown. Then, express it in terms of all other unknowns. Then, letter C, the third step, substitute the whole number values because X, Y, Z, everything are and must be whole numbers. So substitute whole numbers for this. The one that will give acceptable whole number value for variable on the left will be the acceptable value. So let us have this problem. In this particular problem, it says, a man bought 20 pieces of assorted calculators. What do you mean by the word assorted? Assorted means halo-halo, di ba? So, different kinds. Halo-halo, mix-mix. This is a mixture problem, not dealing with chemicals. So, 3 types of calculators and yung assorted, all in all, 20 pieces. Okay? So, he bought programmable, non-programmable, and household type of calculators. Let us say that he bought X pieces of programmable, Y pieces of non-programmable scientific calculators, and Z pieces of household type of calculator. The programmable calculator are 3,000 per piece. Instead of percent concentration absolute, we will put here the unit price. Yung quantity with per instead of percent per piece. Parehas lang. While this one, it says 1,500 pesos per piece, while this one is 500 per piece. Now, according to the problem, he paid all in all for these assorted calculators 20 pieces. He paid here, all in all, 20,000 pesos. The question is, how many of each type did the man buy? How many programmable X pieces? How many non-programmable Y pieces? And how many household type Z pieces? So if we're going to set up our key equation, one is X plus Y plus Z is 20. This is our equation 1. The next is this. If we will calculate the amount he paid for each type of calculator he bought X pieces at 3,000 per piece. So this would be 3,000 per piece times X pieces. That is going to be 3,000 X pesos. While the amount he paid for non-programmable is 1,500 pesos per piece times Y pieces, that is 1,500 Y pesos. While the amount he paid for the household type is 500 pesos per piece times Z pieces, this is 500 Z. You just add them, this plus this will be equal to 20,000. This would be another equation between X, Y, and Z. Now, we have here two equations so far and three unknowns. So, mas marami ang unknowns kesa equations. The problem is, paikot-ikutin man natin tong problem na to, wala na tayong makikita o makukuha na another equation. So, talagang this is only two equations, three unknowns. Ordinarily, since mas marami yung unknowns, this problem is not solvable. But, with exception, this can be solved if the two equations are Diophantine. We shall know that they are Diophantine if all the unknowns, the variables, are whole numbers. Now, my question is this. Is it a must that X, Y, and Z be whole numbers? Yes, because they are pieces of calculators. Obviously, we cannot buy half or one-third piece of calculator. You can buy a part, but not one-third piece. You follow? So, X, Y, and Z are whole numbers, so these are Diophantine equations. How shall we solve them now? We follow the system. The first step is to find the key equation. Our key equation must contain U minus E plus 1 unknown. Our U here, the number of unknowns is 3. The number of equations is 2, then plus 1. So this is going to be 3 minus 2, 1 plus 1, 2 unknowns. Okay? Now the key equation must contain 2 unknowns. This one has 3 unknowns. Equation 2 has 3 unknowns. So, both of them cannot be the key equation. The key equation must contain only 2 unknowns. So, how do we find that equation? Ganito. We work out equation 1 and equation 2. Now, let me simplify first equation 2 by dividing everything by 500. 3,000 over 500 is 6x. 1,500 over 500 is 3y. 500z over 500 is z. Now is equal to 20,000 over 500. This is 40. This would be the simplified equation 2. Tawagin ko lang yan 2 prime, ha? Now let me bring down equation 1 here. X plus Y plus Z is 20. This is equation 1. As you can see, it is simple to eliminate Z now. By simply subtracting the second equation from the first, Z will cancel. So 6x minus x is 5x. 3y minus y is 2y. Z minus z cancels. 40 minus 20, 20. This equation contains now the required number of unknowns to qualify as a key equation. This is now our key equation. The next step, once you have the key equation, is express the key equation in the form of this. y or x as a function of all other variables. Since there are only two unknowns, we just express x as a function of y or y as a function of x. Let me do the latter. So from here, we can have y is equal to 20. Move this to the right, minus 5x all over 2. This is now the form of the key equation which we shall use in our systematic trial and error. We substitute values of x to solve y. Remember that x could be 1, hindi pwedeng 0. 2, 3, up to a maximum of what? Not 20 because y and z cannot be 0. Ang minimum nila 1. So the maximum of x is 18. Anyway, kung nalagay mo hanggang 20, no problem. Anyway, it will yield a not acceptable value. Okay? But we shall not use the manual trial and error. Instead, we will use the mode table facility in our calculator. So you just press mode table, that is number 7 key, then your calculator will ask for function of x. So this is your function of x. So the function of x is equal to your y. So input this in your calculator. So press in your calculator the fraction key, then 20 minus 5x, 5 alpha x, then over, just press the down key, then 2 equals. So your calculator will now ask you, start. It's asking you the first trial value for x you want to substitute. So the first trial value for x is 1, right? Then equals. Then your calculator will now display the end. That is the last x that you want to substitute. So press 18. Now, your calculator now, after you press equals, will show you step. That is the increment of x. If your start x is 1 and your step is 1, then the next value for x will be 2, then 3, then 4. It will just add the step for the next value. So, your step 1, then press equals. Notice that your calculator will now display 3 columns. One is the raw number. The second is the values of x, that is 1 to 18, but the one displayed in your calculator is only 1 to 3 because of the limited screen. Now, across that, the corresponding values of function of x. Remember that function of x is your y. And we know that it is correct if y is whole number. You scroll down the values of function of x or your y, there are only 2 values that you will see are whole numbers. They are when x is 2, y is 5, and when x is 4, y is 0. But while y is 0 is a whole number, remember that y cannot be 0 because the problem says there are 3 types of calculators. If y will be 0, then that condition will not be satisfied anymore. So therefore, y, z, and x has a minimum value or have a minimum value each of 1. So, y is 0 is not acceptable. When you scroll down up to x equals 18, all values of y are all negative. So there are only 2 values, y is 0, which is not acceptable, and y is 5, which is the one that is acceptable. So therefore, our x is equal to 2, our y is equal to 5, and from equation 1, x plus y plus z is 20, our z is 20 minus x minus y. 20 minus 2 minus 5, your z, therefore, is equal to 13. So therefore, the man bought 2 pieces of programmable, 5 pieces of non-programmable scientific calculators, and 13 pieces of household items. For number problems, we have 4 approaches. The one-digit, one-variable approach, the one-digit, all variables approach, and the one-digit, sum-variable approach, and lastly, the substitution approach. The most practical is the fourth. It is important that upon reading the problem, you know which approach to be used. Because if approach number 3 is most applicable and you force to use approach number 1, then you are making your solution unnecessarily long and unnecessarily difficult. So let us have the fourth one, the substitution method. We use the substitution method when the question is find the number. For example, let's have this problem. The sum of all digits of a 3-digit number is 17. The hundreds digit is twice the units digit. If 396 is subtracted from the number, the order of the digits will be reversed. Question, find the number. Notice that since the question is the number, all the options are candidate values for the number, right? So, one of them is the number. Kasi kung hindi sila yung number, then may mali yung question. So, ang gagawin mo lang, what we are going to do is simply substitute them one by one against the conditions. The first condition is that the sum of the digits is 17. So, option letter A, we check 8 plus 5 plus 4. This is equal to 17. So, the first condition is satisfied by option A. Your option B is 683. 6 plus 8 plus 3. This is also 17. This is also satisfying condition number 1. Option C. 864. This is 18. So option C is disqualified. Option D, it's 693. You add them, this is also 18. So option D is disqualified. So after substituting the first option and second option to first condition, 2 were eliminated. Let's go to the second condition. The second condition says the hundreds digit is twice the units digit. Now here, is 8 twice of 4? Yes. Is 6 twice of 3? Yes again. So far, A and B are still good. Now, the third condition says, if 396 is subtracted from the number, the order of the digits is reversed. So, let us check. 854 minus 396. If we calculate this minus this, you'll get here 458. Is the order of digits from 854 becomes 458, is the order of digits reversed? Correct. So, letter A satisfies all requirements. But let us check letter B. 683 minus 396. If you subtract this is going to be 287. So, is the order of digits 683 to 287, is it reversed? It's not. So, therefore, this time, option B is eliminated. So, therefore, our number for this problem, therefore, the answer or the number is 854. So, use the substitution method if the required is find the number. What if the question is not find the number? The question here is find the product of all digits of the said number. So the choices 160, 45, 192, and 14 are not candidate values for the number. They are candidate values for the product of the digits of the number. So the key to solving this problem is first, solve the number. So this time, we don't have a number to substitute against and check against the choices. So we really need to solve this theoretically. So how are we going to solve this theoretically? The applicable solution here is the one variable, one digit approach. When do we use the one variable, one digit approach? Simple. If there is a given condition between the individual digits and you know the number of digits. So those are two conditions to be satisfied. Now, what do I mean by condition between the digits? For example, condition number 1. The sum of all digits of a 3-digit number is 17. So, if these are the digits, the sum of each individual digit is 17. So for you to capitalize on that condition and convert that to equation, you need to represent each digit. That is what I meant by relationship or condition between the digits. Okay? So for each digit, we assign a variable. Let us say this is X, let us say this is Y, and let us say that this is Z. Okay? Alright. Now, condition number 1 says, X plus Y plus Z is 17. This is equation 1. So the second condition says the hundreds digit X is twice the units digit Z. So that is X is equal to 2Z. Let me call this equation number 2. Or I can write this or rewrite this as X minus 2Z is equal to 0. Let me call this equation 2 prime. Now, condition number 3 says, if 396 is subtracted from the number, since this is X, hundreds digit, Y, tens digit, and Z, units digit, the number in equation form is X times 100 or X 100 plus Y times 10 or Y tens plus Z minus 396. So that would be 300 plus 90 plus 6 or simply 396. The problem says the order of the digits will be reversed. Meaning the answer to this is these same digits but reversed in order. That is Z, Y, X. In equation form, that would be Z hundreds plus Y tens plus X. So you simplify this, that is 100X minus X, that's 99X. 10Y minus 10Y cancel. So Z minus 100Z, this is minus 99Z is equal to 396. We divide everything by 99. This would be X minus Z. 396 divided by 99. This is 4. This is equation 3. Equation 1, equation 2, equation 3. 3 equations, 3 unknowns. So you just input this in your calculator. You'll be able to get your X, your Y, and your Z. Your X is, you'll get this as 8, Y is 5, and Z is 4. So therefore, the number is 854. And the product of the digits is 8, times 5 times 4, and this is going to be equal to 160. So the answer is letter A. One variable, all digits approach. When do we use this approach? If the question is not find the number, you don't use this. Second, if there is no condition between individual digits like sum of digits or one digit twice the other digit, then you don't use this one. Lastly, when you do not know the number of digits, you use the one variable, all digits approach. What do you mean by that? Ganito. If these are the digits of the number, we do not know the number of digits, so it is very impractical to let this be x and say that it is thousands digit. Why? Because dun pa lang sa representation nang huhula ka na o nag-a-assume ka. Bakit? Because you do not know that it is a 4-digit number or a 5-digit number. So it means that would be based on an assumption. So the lesser assumption that we do, the more precise our solution becomes. Okay? So that's why what we are going to do here is not assign one variable for each digit. Instead, we assign one variable, let us say x, for all the digits. You follow? So Pacquiao ng x, lahat ng digits. No? Okay? Parang Manny Pacquiao, di ba? Alright. So let's solve this problem. Condition number 1. A number when divided by 2, the remainder is 1. Let's put that in equation form. Let us say that the number is x divided by 2. Let's say that A is the answer, remainder 1. The wordings of the problem reminds us of our division in grade school, right? So example, 7 divided by 2, it's 3. 3 times 2 is 6. 7 minus 6, 1. This is the answer and this is the remainder. Now, the implication of the wordings here is that the answer is a whole number, and that's why there's a remainder. The remainder is also a whole number remainder. Hindi pwedeng hindi whole number ang remainder. So, ang ibig sabihin, the equations we will be getting here are Diophantine equations. Okay? So, yung 3 remainder 1 can be written also as 3 plus 1 half, right? So, 7 halves or 7 divided by 2 is 3 remainder 1 or 3.5 in decimal or in fraction 3 and 1 half. 3 and 1 half is 3 plus 1 half. This is the answer and this is the remainder. This is the divisor. So this may be written as remainder 1 over divisor 2. This is equation 1. Condition number 2 says you divide x by 3. Let's say B is the answer, remainder 2, divisor 3. Condition number 3, when you divide x by 4, the answer is C, remainder is 3, divisor is 4. While when you divide it by 5, the answer is D, remainder is 4, divisor is 5. Now, when you divide it by 6, the answer is E, remainder is 5, divisor is 6. So we have 1, 2, 3, 4, 5. 5 equations, but 6 unknowns. A, B, C, D, E, and X. 6 unknowns. So, the number of unknowns exceeds the number of equations by 1, right? So, this is non-solvable ordinarily. But as I told you, the answer, both the answer and the remainder are whole numbers. So, X, A, B, C, D, E are all whole numbers here. So these are the Diophantine equations. Let us find the key equation. The key equation contains U minus E, yung excess unknowns, plus 1. Excess unknowns is U minus E, right? 6 minus 5, 1 plus 1, 2 unknowns. So therefore, the key equation contains a maximum of 2 unknowns. The difference of this from the other Diophantine equations that we handled before is that all the 5 equations here satisfy the condition of key equation. So all of them must be key equations. All of them must be used all at the same time. Okay? So let us express the key equation one variable in terms of the other. Let me express A, B, C, D, E in terms of X. So what we will have here will be A is equal to X half minus 1 half, or that is X minus 1 over 2. While here, B is X third minus 2 thirds. This is X minus 2 third. While here, C is X fourth minus 3 fourths. This is X minus 3 fourths. While this one, our D, is going to be equal to X fifth minus 4 fifths. It's X minus 4 fifths. While in here, E is X6 minus 5 6. It's X minus 5 6. We substitute here whole values for X. The value of X that will give whole values for A, B, C, D, and E all at the same time is our acceptable value of X and respective values of E. Pero ang problema ito, pag nag-substitute tayo, there are too many substitutions. Kahit mode table pa ang gamitin natin. Saka sa mode table, maganda yun kung isa lang yung equation mo. Kaso, eto, 5 equations. 5 f of x. So, 5 table yan. Diba? So, ang gagawin natin, ito. So, let us reduce the number of trial values. Condition 1 says, when you divide x by 2, the remainder is 1. It tells us something about x. That x is a what kind of number? Odd number. So, it reduces our trial values for x. We will no longer try even numbers. We just try 1, 3, 5, 7, so on and so forth. Pero, it is still too many. But, it helped, right? X is odd. There's another beautiful condition here. Condition number 4. When you divide x by 5, the remainder is 4. It's easy to know whether a number is divisible by 5, right? It ends with 0 or 5. So if it has a remainder of 4, you just add 4 to that number. So if it ends with 0, you add 4. The ending now is 4. If it ends with 5 and you add 4, the ending digit now is 9. But if the ending digit is 4, it's an even number, right? Condition 1 says x is odd. So, it cannot end with 4. So, this condition confirms that x is a number ending with 9. So, our trial values now reduce to numbers ending with 9. X ends with 9. So, our trial will be 9, 19, 29, 39, 49, 59, 69. The first value of x that makes E, C, and B whole numbers will be the one that we will accept. So, in order for us to just use one substitution, we use the function colon and calc in our calculator. So, input this in your calculator, fraction alpha x minus 2 over 3 colon, then fraction x minus 3 over 4 colon, then fraction x minus 5 over 6, then press calc. Your calculator will ask you to input your value or trial value for x, right? So we now substitute the values for x in this equation 2, 3, and 4. If we use the function colon and calc in our calculator, it is a must that b, c, and e will be whole numbers. So we try x is 9, 19, 29, 39, and so on. So in order for us to just shorten our time of substitution, we use the colon calc function in your calculator. So kung walang colon calc, then we have to do the manual tabulation. Sure ako, mode table ang calculator mo, no? Okay. So what we will do here is input this in your calculator, alpha x minus 2 over 3. Okay? So that is alpha x minus 2 over 3. Then colon, alpha x minus 3 over 4. Then colon, alpha x minus 5 over 6. Then you press calc, meaning you are calculating these functions for every value of x. Now, upon pressing calc, your calculator will ask you what is your x. So it prompts you to substitute values for x. No? Okay. So we try our first value of x, 9. Press equals. Once you press equal sign, it will give you the value of this one, the b. So that is 9 minus 2, 7 over 3. That is not a whole number. Okay? So you press equals, your calculator automatically gives you this value, which is 9 minus 3, 6 over 4. Your calculator displays 3 halves. That is not a whole number. 9 is already rejected by this, no? Because B, C, and E must be whole numbers. Okay? So, we press equals, your calculator displays the value corresponding to 9 minus 5, that is 4 over 6, that is 2/3. So, all of them are non-whole numbers. Okay? So, we press again equals, your calculator requires you to input another x. So, 9 is rejected. So, we try 19. So, this gives you 17 over 3. That is not a whole number. So, press equals, the calculator displays the value for this. Press equals, displays the value for this. We are no longer interested with this because 19 is already not acceptable because this must be whole number. Okay? So, press equals again. You will return to this. Your calculator asks you to substitute the next value for x. So, we try 29 equals. So, this is 27 over 3. Your calculator displays 9. Whole number. But it doesn't mean that 29 is already acceptable. C and E must also be whole numbers. So, press equals. Your calculator will give you 13 over 2. That is not a whole number. So, 29 is not acceptable. Press equals, it gives you the value for this. Press equals, your calculator will ask you another x. So, try 39 equals. Your calculator displays 37 over 3. That is not a whole number. So, 39 is rejected. So, equals, equals, equals. Okay? Your calculator asks another x. Try 49. So, your calculator displays 47 over 3. It's not a whole number. So, press equals, equals, equals. Then, calculator asks us another x. Try 59. So, 59 minus 2, 57 over 3. Your calculator displays 19, whole number. So, equals, so your calculator displays here 59 minus 3, 56 over 4. So, your calculator displays 14, whole number. So, press equals, it is 59 minus 5, 54 over 6. Your calculator displays here 9. B, C, and E are whole numbers. So therefore, X is 59. And the smallest digit of the number is 5. So therefore, X is 59. Smallest digit is 5. Okay?